No, sir.
Video is off, na? Please check my video. Is it off? Mutakabir.
Yes, sir.
Yeah, audio is okay, na?
Yes, sir. No, it's okay.
Okay, let us start. So in last class we have seen image processing related some introduction and image processing with the help of iMac also seen. In last class I have shown you image representation using iMac. Then I have shown you image acquisition. Today we will see these three image processing techniques. One is the image transformation, another one image histogram, and the last one image segmentation. So image representation also I have shown you in last class. So this is neighborhood also I have shown you in last class. Acquisition also cover in last class. Okay, let us start this transformation. The meaning of transformation is nothing but, suppose we have an image represented with letter P and we want to transform this into the in the form of Q. Okay, so during this transformation we will perform some changes operation. Like suppose we want to transform time domain signal into frequency domain signal. So what we will do, we will use Fourier transform. So when Fourier transform applied on the signal, so the signal is transformed from time domain nature to frequency domain nature. So exactly in similar way, the nature of image can be transformed to some other form in the interest of doing image processing operation. So definition of image transformation is on your screen. It is used to obtain a modified image starting from an input image for improving human perception or for extraction of information in computer vision. So these are the two aims for performing image transformation operation. Is it clear or not? Let me know.
Yes, sir. Yes, sir.
Yes, sir.
Yeah. Basically, there are many many forms of transformation. We will see only two. One is punctual operation, another one group operation. So now let us see punctual operation. There are many punctual operations. The first one is on your screen, that is called as identify function. In this case, the output image Q is just a copy of input image P, right? So when the input image P is identify function. Okay. Second one is called as negative function. Negative function means all the pixel value. I am considering the case of the grayscale image. All the pixel values are subtracted with 250 image. You see, the output image Q is given by this relation 255 minus input image P. Suppose this is our grayscale image. By doing inversion operation or negative function operation, we will get image like this. So, hope it is clear to everybody.
Yeah, yeah, sir.
Yeah, now I'm moving to the next slide. The third punctual operation is called as thresholding function. In case of thresholding function, what we will do is, based upon the value of input image, we use some thresholding for comparison. If suppose input image is less than or equal to the set threshold value, we make it to 0. The intention of doing thresholding operation is to convert grayscale image into binary image. Binary image ke andar, I told you already, all pixels value will be either represented as 0 or 255 or 0 or 1. Is it clear to everybody?
Yes, sir.
Yeah, if suppose we wanted to make binary image, we take the help of thresholding function. In case of thresholding function, the output image Q is either substituted with 0 or substituted with 255. It is substituted with 0 if the pixel value of input image is less than or equal to threshold value, and it is substituted with the maximum 255 if the pixel value of input image is greater than a threshold value. You see, in this particular example, using iMac Vision, the threshold value is set as 150. 150 is set. Okay. So when in this case, what happens is any value of pixel which is greater than or equal to 150 is replaced. Greater than 150 is replaced with 255. Less than or equal to 150 is replaced with 0, and the result in image after thresholding function is this one. This is normal image and this is thresholded image, or this is binary image. Is it clear to everybody? A binary image में देखो आप क्या दिख रहा है आपको, खाली black and white दिख रहा ना. You see, this is totally black
Yes, sir.
and this is totally white, but this one is having different combinations, slightly more than black or slightly less than white, so little gray or like that. So like that, different combinations of colors are, so not color, the variation from white to black is there in this grayscale image. But in case of this binary image, we observe only two colors. One corresponds to black, another corresponds to white. Is it clear to everybody?
Yes, sir.
Yes, sir.
Yeah, punctual operation is over. Now let us see group operation. Group operation. For group operation, we take the help of the neighborhood mask. I was telling you, the neighborhood mask is actually a way of representation of pixel. So the neighborhood mask actually is used in order to perform group operation for transformation. So it corresponds to operation that take in consideration of a group of points. Okay, so a group of points are considered in order to perform operation on a particular pixel. See, let us suppose that we want to perform operation on the coordinates x comma y of image Q using this particular mask. Okay, let us see how we can write this equation. I told you row corresponds to x and column corresponds to y.
Why?
अब इधर देखो आप -1 x minus y. The second one is x and the third one is x plus y. Okay, so you see the position of the x coordinate with respect to the element -1. If it is -1, we write in case of x minus 1. With 0 we write as x. With 1 we write as x plus 1. Similarly with -2, second row, it is again x minus 1. With 1 it is x. With 2 it is x plus 1, meaning this element is corresponds to x minus 1, this is x, and this is x plus 1. Is it clear to everybody? If you go in
Yes,
row,
sir.
it is for x.
Yes, sir.
X minus 1, x minus 1, x plus 1. Now let us see the case for y coordinate. Y coordinate means we need to see from the column. Okay, okay, you see from the top. I'm considering this column, first column, -1, -2, -3. So for this case, -1, -2, -3. For this case, you see this corresponds to y minus 1, and this corresponds to y, and this corresponds to y plus 1. Same apply to second column. Okay, you see this is y minus 1, the middle one is y, and the last one is y plus 1. Similarly, consider the last column. Okay, this corresponds to y minus 1, the second one corresponds to y, and the last one corresponds to y plus 1. This is a simple exercise in order to understand the operation of masking. How can we apply the masking operation on a particular image, a particular output image from the input image P? Is it clear to everybody?
Yes,
Up to
sir.
here? Yeah,
जी
you
sir.
see,
Okay.
you see the output image Q is represented in terms of image P. इसको क्या बोलेंगे मैं मालूम है, mask बोलेंगे, mask, right? Okay. Usually the group operation is used to perform filtering operation, and there are two types of filter. One is high pass filter, another one low pass filter. In case of image processing operation, okay, the mask which we use to perform high pass filtering operation is this one. All elements are 1 by 9, 1 by 9, 1 by 9. Okay, if we use this particular mask and make the output image, then in that case the corresponding image will become high pass image, meaning it permits only high frequency information. All low frequency informations are filtered out. Okay, similarly the mask for low pass filter using 8 neighborhood is this one. A first row all minus 1 and last row all minus 1. The middle one is minus followed by 9, minus 1 followed by 9 followed by minus 1. Is it clear to everybody?
सर लो पास फिल्टर समझ में नहीं आया.
कुछ भी नहीं है बाबा. It is just a mask. Okay, it is just a mask. Take it for granted. Why? Because you are not studying image processing subject. You are studying iMac vision, right? LabVIEW, image processing using LabVIEW. That's why some of the things you may not be able to fully understand. Okay, just take it for granted that this mask is used for low pass operation. Low pass operation means an operation in which only low frequency content will be retained and all high frequency contents are
Be
filtered out,
attenuated.
right? Okay, can I go to next slide?
Sure sir.
Yeah, histogram. ये histogram बहुत अच्छी चीज है. देखो, histogram is like our PhD. Okay, it is used for analysis, big analytics operation, one of the important tool of big data analysis. Okay, you see, the meaning of histogram is it's a curve that contain number of pixels in an image at different intensity value. इसका मतलब क्या है? The x axis is intensity value and the y axis is, okay, and the y axis is number of pixels at that particular intensity value. अब मैं एक केस कंसीडर कर रहा हूं. ओके, ये देखो आप, ओके, with there are 1000 images available. In this particular image picture whose intensity is 50. अच्छा, मेरे को ये बोलो आप, ग्रे स्केल इमेज की इंटेंसिटी कहां से लेके कहां तक रहती है बाबा? इफ वी यूज
0 से
8 bit representation.
0
Very
to
good, very good. इधर देखो, that's why you see the x axis is varying from 0 to somewhere
250.
around 250. So it means that x axis is what? The intensity of image, right? Intensity of image.
Yes.
अब यहाँ देखिए आप, जीरो इंटेंसिटी के कोई भी नहीं है, और आपके इधर आ जाओ, ये वैल्यू के ऊपर इट इज लुकिंग टू बी हाफ ऑफ 50, हाफ ऑफ 50 टू 25 इंटेंसिटी के कितने हैं भाई? 1000 को हाफ, 1000 को, अच्छा, ये दिस इज 1000, दिस इज समवेयर 500, so 400, there are 400 pixels, okay, with intensity 25. Similarly, now I'm considering the peak, okay, peak, this one, somewhere 150 और 100 के बीच में क्या आता भाई? 125 है, समझ जाओ, ठीक है? हाँ, 125, this point is 125. At 125 you see around about 4000 or little less images, pixels are of intensity 125 can be seen. ये क्या दर्शाता मालूम है? What this histogram picture is showing is how many pixels are available in our image of that much intensity. Accordingly, we can select the masking operation. Is it clear to everybody?
Yes.
Yeah, इधर देखो, iMac vision we are using, to which we are giving an image and selecting the configuration as grayscale 8 bit Okay, and using the function histogram. ये वाला जो display है ना, ये normal, ये this display is for this picture, and this display is this one because it is gone through the histogram function. Okay, so because of the histogram, the waveform is looking to be like this, in which x-axis is the intensity and y-axis is number of pixels of that particular intensity. So hope you all understand what is the use of histogram, right?
Yes, sir.
Let us see the case of RGB image. I'm sorry. Let us see the case of RGB image. If we wanted to find out the histogram of this particular image, you see we are getting three different waveform. Okay, one is for matrix red, one is for matrix green, and one is for matrix blue, RGB. Is it clear to everybody?
Yes, 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 sir.
Yeah, that's it for image processing. So hope the unit 5 is clear to everybody. So shall we quickly recap the thing covered in image processing operation? Not, I think really not necessary. Okay, because maybe some of the people just join. I just cover it for next 3 minutes. I told you image is a two-dimensional vector. Okay, in which x corresponds to row, y corresponds to columns. Binary image contain only two information about the pixel, one for black, another for white. If we use 8-bit decoding, so the matrix containing only 0 and 255 information. So what we will do is all black and white image we try to represent in grayscale. So the grayscale decoding can be represented with the help of 0 to 255 number. So in case of grayscale decoding, we have in numbers varying from 0 to 255. It is not binary image, and it is also not color image. Okay. So example is shown here. If the image, if the pixel of the image is totally black, it is represented with 0. If it is totally white, it is represented with 255 number. Between black and white, different numbers are used. Okay. The next topic is the color image. The color image is multi-plane image. It is having, instead of one matrix, a three matrix, right? So this is actually the representation of grayscale image, or any binary image. So the row corresponds to x coordinate, y corresponds to the column coordinates. Okay, this example is shown for the element of third row, ninth column. Okay, this is digital image representation for grayscale. So here the matrix will be represented with numbers, but here in order to make the clarity, it is represented in the form of their representation. So here it is shown that if it is 165, it is not exactly the white, not exactly the black. If it is 0, it is exactly black. The dark 0, the dark black is represented with 0, and the dark white is represented with 255. The color image is usually represented with three matrices. The standards are available. Two standards are available. One is RGB, another one HSL. RGB stands for red, green, blue. HSL stands for hue, saturation, and luminance. In the presentation, RGB is used. Actually, the object of the content presentation is to use LabVIEW to show the image processing operation. Okay. So on the screen, the color image representation is shown. You see there are three matrices shown, one for red, another for green, another for blue. Then we move to image processing using LabVIEW. In that, there is a toolkit. It's not a part of default LabVIEW application software. We need to externally buy it, so which perform image processing operation, and the name is iMac. So If we use our application software and we are using iMac also, it comes with additional front panel. So with the help of which all image displaying or image controlling operations one can do. So in addition to having a default front panel block diagram, we need to have an additional front panel for iMac control and indication operation. Then I have shown you a few image processing operation which we can do with the help of iMac. So listed are 5. There are many. Don't think that only the listed are the enough image processing operation available because we need to study a few. It's actually a subtopic of Unit 5. So that's why only 5 I am picking. This is one of the biggest application of big data analysis. Please remember this. Okay. Image representation, image acquisition, image transformation, image histogram, image segmentation. Image representation. किसी की आवाज आ रही है? ऑडियो बंद कर दीजिए. Image representation. Suppose we have a color image and we want to get the grayscale image. So the standard way of doing this thing is perform addition operation of this 3 matrix. Okay, which corresponds to color image. The standard percentage value which we take from each is like this. From red we take almost 30%, and from green almost 60%, and from blue almost 10%. Okay, then I have shown you the image representation with the help of their neighbors. So there are 3 standards way of representing any image with their neighbors. First one is 4 neighbors, second one is 8 neighbors, and third one is D neighbors. In case of 4 neighbors, the object is actually targeted using their 4 neighbors, which is shown here on this screen. In case of 8 neighbors, the surrounding all 8 neighbors are used if you want to target to this particular image. Similarly, in case of D, the diagonal 4 neighbors are used. This one, this one, this one, this one, in order to target to this center image. Image vision. So this is the basic operation every image processing tool should provide. That with the help of that, external image can move into computer. That is called as image acquisition. So vision acquisition Express VI is available as part of image toolkit. So with the help of that, this operation can be done. Now moving to image transformation. Image transformation is actually, I told you, the intention of this is to get these 2 objectives. One is to improve the human perception or to extract the information needed for computer vision. Okay, under this we perform 2 types of operation: punctual operation and another one group operation. So under punctual operation we see 3 different functions. First one is the identify function, meaning in that case the output image is just simply equal to input image. Okay, the transform is doing nothing. In case of negative function, so the output image Q is actually subtracted from the maximum value. Okay, so this is actually called as negative image, or it is also called as inverted image, right? Inverted image, right? This is actually the grayscale. If we perform a negative or inverted operation on these, we will get like this. Punctual operation. Punctual operation means sometimes we actually wanted to convert grayscale image into binary image. In that case, we apply some thresholding function. So the output image Q will be replaced with either 0 or 255 after a check on the input image pixel P. The threshold value can set to any number. Okay, usually it's set in the middle of 255. So the standard one is shown here in the example, 150. If it's set 150, you see the grayscale image is converted into binary image, and then it's looking like this. Now the last one I have, okay, under image transformation I have shown you group operation. Group operation means, suppose this is the output pixel, corresponds to this position. Okay, suppose this is X and Y position. Okay, so for this, if we want to apply this mask, then the p value of pixels, whatever, okay, is okay, this value minus 1 times this value of pixel of p and this value of pixel of y is added with the 0 into this. Okay, it's very difficult for me to explain you all these things. Just you take this as, okay, the center value position of the image x comma y, if we want to calculate, okay, using this particular mask, this is the expression we use. Detailed explanation I have given you earlier. So this is for example. Usually a group operation of transformation is used to perform, okay, filtering operation. Available filters are high and low. Sharp edges. Sharp edges can be removed with the help of high pass filter, and the reverse can be done with the help of low pass filter. If you want to target to perform high pass filter operation, this is the mask we can use. And if you want to perform low pass filtering operation, this is the mask we can use. And this operation we will perform for all pixels of the output image. And the last one is histogram. In case of histogram, let us suppose that actually we wanted to calculate this particular image is containing which value of intensity, more pixels. Okay, in this case you see 125 intensity is coming, looking to be almost for 40,000 pixels. 40,000 pixels are belonging to category 125. And this is the image histogram shown for color image. So in which there are three graphs, one for each color. Okay, that's all for image processing operation. So what I will do is we'll stop the recording so that it become a part of image